All right, welcome to this screencast of formula writing for ionic compounds. So we've got 4 examples here. We're going to step you through one at a time how to write the formulas for each of these ionic compounds. We can recognize them as ionic compounds because they contain one metal, usually the first one written, as well as one nonmetal. Anytime you see something end in an ate or an ite, or have another polyatomic ion, we definitely know that that's going to be an ionic compound. So let's take a look at these one at a time. So we've got sodium oxide. We can start off by writing the symbols for the 2 elements that are involved in this compound. So sodium symbol is Na, oxygen symbol's O. And then we're going to need to look at the periodic table to see if we can find out what charges each of these elements have. Since sodium is in group 1, it's going to lose 1 electron, get a positive 1 charge. And oxygen's over there in group 16, it's going to lose, or it's going to gain 2 electrons, to get a -2 charge. Since we know these compounds altogether must have a neutral charge, we have to balance out these charges. So if we have a -2 charge and a +1 charge, we definitely know that we're going to need 1 more positive charge. So we're going to need 2 sodiums. The other way to look at that is if we just take the value of our charge, not the plus or minus part, and use those as our subscripts for the compound here. So that would be Na2O. We don't ever write 1 as a subscript. So let's clean that up a little bit. Na2O. We're going to need 2 oxygens, 2 sodiums for 1 oxygen. Sorry about that interruption. Take a look at the next one here. We have iron 3 nitride. If you notice, iron is an element that's in the transition metals. And transition metals, we can't tell what their charges are based on their location on the periodic table. So we need to include their charges whenever we write out the name that contains an element with a transition metal, or a compound with a transition metal. So same deal as we did before. We're going to take our symbols, Fe for iron, and nitride, IDE ending. That means we're dealing with just the element nitrogen. So it would be FeN. Well, nitrogen's in group 15. Elements in group 15 gain a -3 charge. Iron can't tell its charge based on its periodic table location, so you have to look to the Roman numerals. So that's Roman numeral 3. That must mean that iron has a +3 charge. Well, if we did the crisscross, it'd be Fe3N3. But if you look, our +3 is going to cancel out our -3. So all we just need to do is write out the formula FeN. That is iron 3 nitride. Then if we take a look at the next example here, we've got ammonium sulphide. Well, you'd be here all day looking for ammonium on the periodic table. Ammonium is not on the periodic table. It is a polyatomic ion. So you're going to look to the sheet of polyatomic ions, or look it up, and you'll find ammonium has a formula of NH4 with a +1 charge. It's rare in that it is a positively charged polyatomic ion. And sulfide, again, that IDE ending indicates that it's just the single element sulfur. And sulfur is right below oxygen on the periodic table. It's a group 16. Like all elements in group 16, it's going to get a -2 charge. And we know we're going to need another ammonium ion to balance out this -2 charge of the sulfide ion. So to show that, we're going to take NH4, ammonium, and to show that we need more than one of them, we're going to put it in parentheses and put the number of ammoniums that we're going to need as a subscript outside the parentheses. And then we're going to add to it the sulfur. If we take a look at this last example here, cobalt 3 carbonate, ends in ATE, so this should be a sign that we're going to have to look to the sheet of polyatomic ions. We're going to see that cobalt symbol is CO with a +3 charge. That +3 comes from those Roman numerals there. And carbonate, it's got a formula CO3 with a -2 charge here. Be very careful. What's the difference between a carbonate and a cobalt 3 cobalts? Well, cobalt is a capital C with a lowercase o. Carbonate is a capital C with a capital O, denoting a carbon and oxygens here. Well, as you can see, our charges don't cancel out. So to find what the charges of the formula is, we're just going to take our charges and use them as subscripts. So we're going to need 2 cobalts, and we're going to need 3 carbonates. That 3 is part of what makes carbonate carbonate. That 3 shows that we have 3 carbonates.